This tutorial is going to be about OSPF and how the OSPF DR and BDR elections take place. The DR and BDR elections are designated router and backup designated router elections that take place in a multi-access OSPF enabled network. What I've done so far, let me explain what I've got. And this packet tracer file, you can download it from my website at danscourses.com, and I'll have the link below in the video description. So you can just follow the link to get this starter file. Now, what I have so far is all of the interfaces on the routers have been configured. Okay, but I haven't enabled OSPF yet. And on router 0 here, I've listed some sample commands that you're going to want to know. All right, so R0 is right here. Here's router 0, R0, R1, R2, and R3. And this is the ISP router. Here's the sample commands for R0. I have not put in the OSPF commands yet, though. Okay, and what we have here is we have LAN, local area networks here on the outside, 1, 2, 3, and 4 here. This is the 192.168, 1.0, 0.0, 3.0, and 2.0. And the numbers match the routers. So the 2.0 network is R2, and the 3.0 network R3. The 0.0 R0, and the 1.0 is R1. And then in the middle here is the 192.168.50 network. And the interfaces have been configured. R0 is the best router of the 4 routers. So the goal will be to make R0 eventually the DR, the designated router. And as the designated router, R0 will hand out all of the link state updates, all of the link state packets. We'll distribute them to all of the other routers. So it will be the one that hands out all the packets, and that's going to create less traffic on this multi-access network. You can see how all these routers are attached to this switch, right? So he's going to be 50.10, and then 50.1, 50.2, and 50.3. So ideally, this router would be the DR, right? And maybe this router would be the BDR. But it's not just these interfaces on the inside that sometimes influence the election process. It's also the IP addresses sometimes on these outside interfaces. In fact, there's multiple things that influence a DR and a BDR election, and we're going to be looking at that. Okay, then over here what we have is the ISP router, and the ISP router is emulating the internet service provider, and it has the way out to the internet. Now this way out to the internet is actually just going to be a default route out of the loopback 0 interface, which is configured at 200.10.10.249. That's the 248/30 network. Okay, and so we need to create that default route to the internet for this ISP router. So he's emulating the way out to the internet. Then on this interface over here, we've got, in this network right here, we've got the 200.10.10.252 network /30. And you can see this router is 253, and this router is .254. And what we're going to do is on this ISP router, we're going to put a summary route that summarizes all of these networks here. Right? So this ISP router will not participate in OSPF. All right? And this router will participate in OSPF on the blue and the orange networks, but it will not participate on the green networks on OSPF. It won't participate on this interface, the serial interface. So this R1 router is going to need to distribute a default route to all of the other routers to let the other routers know that there's going to be a static route going out of this interface, and we need to configure that. And so I've listed here that R0, R1, R2, and R3 are all going to be running OSPF, these routers here, and it's going to be OSPF single area, OSPF area 0. And once again, this network in here is an Ethernet network, so it's a multi-access network, and they're all connected to the same network. So we're going to have DR and BDR elections that take place because of this situation right here. And we're going to talk about that. So let's start doing some configuring. I'm going to click on the ISP router and set up that default route out of the loopback interface. All right, so what I'm going to do is, let's see here, I will hit enter. You can see it says ISP. We're in the ISP router. Enable conf t to get to configure terminal, right? And what we want to do is we want to set an IP route, so it's a static route, to the 0.0.0.0 space 0.0.0.0, and we're going to go out of loopback 0, so I'll just say out of LO 0. All right, and there is a default route now out of the network. Now what we need to do is we need to set up our summary route going the other way, and the summary route needs to summarize these networks here. And so I've typed this up to help explain that situation. So the summary route, you can see here that we have the 192.168.0 network, the 1, the 2, the 3, and then the 50 network, right? Now, the ISP router is actually connected to these 200 networks here. So we don't have to summarize these 200 networks. We have to summarize these networks that this router doesn't know about. Not the connected networks, but the routers that it doesn't know about. So I've put here summary route 192.168.0, and we've got to go all the way up to the 192.168.50 and create a summary route. So the question becomes, what is the subnet mask? Well, if we use a subnet mask that is 8, 16, 18 ones, then this last one right here would be in the 64's place, meaning magic number 64. And what that means is the subnet mask would be 255.255.192, right? So here's your 255 and your 255, and then 128-bit plus 64-bit, right, is 192. So it would be 255.255.192. Now the magic number is 64, and so what that means is it would summarize the 192.168.0 network all the way up to 192.168.63.255. So the next network that it would, the only network that it would not summarize would be 64 and up. So this would summarize 0 to 63.255, and that would cover our networks because we have a 0 network all the way up to a 50 network. And so this is going to be our subnet mask. So our answer is going to be the summary route, right? So summary answer will be 192.168.0.0/18. And that's going to summarize 0 to 63.255. All right? And we're going to put that in right now. So we'll click on this router, and then it's got serial 0 interface right there. And we'll put in another static route. So we'll say IP route to the 192.168.0.0 network, and we've got to put in the correct subnet mask though. So we put in 255.255.192, going out of our other interface, which happens to be serial 0/0. All right, and that's going to set up a summary route. It'll reach all networks from 192.168.0 to 192.168.63.255. All right, and it says here invalid interface and number. Okay, so if the response from the router was invalid interface type and number, I must have gotten serial 00 wrong. So let's take a look. If we look at our router and we hover over here, you can see that it's actually serial 0/0/0. Well, that's different. So now what I'll do is I'll just type up arrow and put in another /0, and we're good. So now we've got two static routes. All right, and if we look at our show running configuration, or in fact, let's do one better and look at show IP route to see our routing table, you can see that we have a static route, which is a summary route, right? Or in fact, not just a summary route, it's a supernet route, because 192.168 would normally be /24, And since it's less than /24, it's also a supernet. And then we've got two connected routes here. You can see our connected routes, one to loopback 0, one to serial 000. And then we have a static route, a default route, or gateway of last resort, candidate default route, 000, the 0 subnet mask out of loopback 0. So the ISP router now is all set up.